all of the materials that he'll be using. So yeah, the question about materials, I don't believe you have access to those right now, but you will have access to those on Friday. I will just in a second, I'll type in the URL where you can find those. If you have any questions as we go along, please just type them in the chat panel, and either we'll answer them there or I'll pause Scott and ask him to address some of your questions publicly. So, Scott, you ready?
I am indeed.
Okay.
Okay. Welcome. I'm delighted to be able to do this webinar with you today. As the description suggested, we're going to concentrate on activities for elementary and middle school students, although some of these activities you'll find will have significant application at the high school level. The things we'll look at in the earlier grades include some activities around integers and moving on from integers to decimals as we explore number lines and so forth. Activities around multiplication and factoring, and activities related to fractions. As we move on to the middle school level, we'll be looking at some geometry activities, some early algebra activities, and an activity related to data. As we go through these, I'm going to look at several of them in somewhat more detail. So we'll spend a little bit of time going into those activities deeply, but we'll also survey a significant number of activities very quickly, just to give you an idea of the wide range of activities that we have available, and that way we also can show you the kind of support that we provide for these activities in the ones that we go into more deeply, even as we show the range by doing some quickly. So you already know who the folks are today. I'll skip over that slide. I do want to talk briefly about why it's important to use Sketchpad for our budding young mathematicians. One of the aspects of it is that by actually manipulating the mathematics themselves, students have a way of engaging with it that goes beyond what they can do with more static materials. By dragging points and varying numbers, students can explore the behavior of various mathematical objects. They expand their mathematical thinking by being able to explore lots of situations very quickly, much more quickly than they could with physical manipulatives. And the visual images that are created allow students to develop the abstract concepts through that sort of visual imagery that these activities provide. So let's go on and look at the first activity. This one's called Find the Secret Number. I should mention that all of these activities you can see on the original title page are available from one of two places, either the Dynamic Number Project or, as I said here on the title page, the Dynamic Number Project or Sketchpad's Help menu. And I'll show you Sketchpad's Help menu in a moment. Okay, so we're looking at the first Find the Secret Number. And this activity comes with a worksheet. And as many of our activities do, it also comes with a movie giving you some hints as to how to use the activity effectively. And I'll show you the worksheet and the movie in just a moment, but let's play the game first. We are supposed to find the secret number. How many clues are we going to need? And we can make a guess by moving the gold pointer anywhere we like. One of the objectives of this activity is going to be for students to develop their thinking about how they actually find the secret number. But let's go through it first without worrying about strategies. I think the number's probably 2, so let me make that as my guess. Checking, checking. Oh, goodness. Boy, am I good at this. Well, time to start a new game. And I'm going to guess this one first guess also. I think this time it's 8. Okay, check my guess. Check. Oh, shucks, it's less than 8. Okay, so now I have to figure out what that means. If it's less than 8, I can eliminate the numbers 8, 9, and 10, and one way of eliminating them, one way of keeping track of what I've eliminated is by dragging these gray triangles. In fact, I can drag them anywhere I want to show what numbers are still possible. So to show that 8, 9, and 10 are now impossible, I drag the gray triangle to keep track of what numbers I should still be looking at, and now I'm going to guess, I think it's 1. So check that guess. No, x is less than 1. Ooh, that's a good hint. If x is less than 1, I only have one chance left. It's got to be 0. Let's see. Terrific. Okay, so that time I used 3 clues. The worksheet actually has a set of boxes for me to keep track of these things in. So I would write down as I'm going. For instance, on this last one, I should cross out the 8, 9, and 10 on the worksheet. When I eliminated those numbers, I should write down the clue that I got here, the x less than 8, indicate that the remaining suspects are from 0 to 7. And in that same way, I could write down the clue and the remaining suspects and keep track of what I've eliminated. The idea of doing this in 3 different ways, both crossing out on the number line on the worksheet, keeping track of the clue and the suspects, and keeping track of the suspects with the gray triangles, is to make kids think a little bit more deeply about what these clues really mean, to help them keep track of the greater than, meaning of greater than and less than, and to generally focus their attention on what the clues really mean and what they can figure out. So this activity comes with a number of different levels to it. 0 to 10 is where we start. As kids get better, and as their strategies develop, they can go up to 0 to 100, 0 to 200, and so forth. There are a number of different pages with different levels where strategies become more and more important as the number of possibilities increases. I also just want to show you the first maybe 15 seconds of the movie to give you a sense of what's of the sort of support that the movies provide as well. Okay, that's enough. You get the idea of the movies. And those movies can be very helpful in formulating your presentation to the students and in giving you some ideas about how to use the sketch effectively. Okay.
Scott,
yes.
This is Josephine. I just want to pause you for a second. I didn't hear that movie, and I think probably nobody else did too. I believe that when you play a movie on your computer, that actually doesn't transmit via the webinar, unfortunately.
Okay, well, I apologize for that. I wasn't going to show any more movies anyway. I didn't want to spend more than about 15 seconds on the movies. It began to talk about the importance of things like students learning the meaning of the greater than and less than signs, but that's enough about the movie. You should download, when you download the activities, the ones that have movies, download those as well and take a look, and you'll see for yourself whether they're useful to you or not. I think you'll find them helpful.
Scott, we also had a couple of questions about the number lines, if they could include negative numbers or fractions.
This particular model is not designed to show negative numbers or fractions. We have a number of, we have several other number line models that we'll be looking at that do involve negative numbers and fractions, but not this one. This one is, I've used this one with second graders, and And that's an interesting question. I think this activity would actually, so that's another activity we ought to write. We ought to write an activity that extends this to negatives and to fractions. Why not? That would be fun. Okay. The next activity we want to look at is another number line activity, but this is an activity that uses an open number line. And what I'm showing right here is a completed sketch involving 17 plus 78 in two different ways. And we'll come back to that in a moment, but I want to show two things about this activity first. I want to show the teacher notes, because in addition to the worksheet, we have extensive teacher notes that detail, for instance, how to introduce the activity to the whole class, how to demonstrate for them how to use the sketch, and then if it's an option for you, if you're able to do this with students at the computers themselves, what to have students do at computers if you have enough of them, and then some suggestions about the class discussion that you ought to lead at the conclusion of the activity. So call the students together, summarize what they've learned. Here are some points that you want to be sure come out of the discussion as the students reply and as you get students talking about what they saw and what they did. So those notes are important suggestions to you as to how to effectively use the activity, how to lead the initial discussion, and how to lead the concluding discussion. Now, this particular activity is slightly different in this sense that although it's a prepared activity, it actually uses some special, what we call custom tools. And those custom tools are in the activity sketch itself. I don't have the custom tools here in my presentation sketch. So I'm going to switch to that activity sketch. And here we are in the activity sketch. And I'm going to show you how this activity sketch uses those custom tools in order to accomplish, for instance, this particular problem, which is the very first page of the sketch. The custom tools are found at the very bottom of the toolbox, and this particular document has tools for a number line and a tool for an arc with value. Those are the two that we'll use at the moment. So a new number line just gives me a number line with a 0 on it. Okay. And we want to find 17 plus 78 in two different ways. For that, we're going to use the arc with value tool. So to make the arcs, I'm to match a measurement here for the length of the arc, and I only have these numbers to match. So if I want to get to 17, one way to do it, since I don't have 17 in here, would be to start with 10. And there's an arc that takes me to 10. I've got my number line too high, so my arc is overlapping with my directions, so I'll move things down a little bit. So that's gotten me to 10. I'll go back to my arc with value tool, and I could finish up getting to 17 by using a 7 arc. So the whole point of this activity is to encourage kids to decompose numbers in various ways. Let me keep going and do the 78 now. Let's see, to do 78, I'm going to start with 70. So that gets me up to 87. And I need 8 more added onto the 70. So the sum should be 95. Let me try it a different way and see if I get the same result. New number line. And this time, 17 is just a little bit less than 20. So let me go to 20 first, and then come back by 3. So if I go 3 to the left of 20, I get -3, leaving me at 17. So far, so good. Now 78 is just a bit less than 80. So if I go 80 in the positive direction, and then, let's see, 78 is 2 less than 80, so I should come back by 2, and I end up at 95 in both ways. Now you notice this is an open number line. What an open number line means essentially is that you don't have the actual markings on it, but you use it in a way that you think about, well, I've done a jump of 10 and a jump of 7, so I get to 17. So it's a number line where the actual positions don't have to be accurate. And the point is for students to get used to the ideas of composition and decomposition of numbers to make it easier for them to understand how the numbers fit together and how they can eventually do these sorts of problems using mental mathematics. Okay. Are there questions I should answer before going on to the next activity?
I don't believe there's any questions you need to answer now, Scott. Thanks.
Okay. So the next activity I want to show is a place value counter. And the place value counter activity, I forgot to put a button here for the worksheet. But the worksheet is going to give us some target numbers, and we'll keep track on the worksheet of what we did to get to those particular numbers. So let me just make up a problem here. Let's say we're trying to get to 925,463. So to get to that number, I could take an approach of clicking 1, 2, 3 in the ones place and 6 here and so forth, or I could do it really in any order. As I work on this, I may start to develop other strategies besides just going straight across from the ones place up to the 100,000s place. For instance, I might realize that if I started with a 1 in the millions place and subtracted 1 in the 100,000th place, I've gotten this digit correct in only 2 button presses instead of taking as many as I was taking on these first few. So that allowed me to get to my number in only 22 button presses instead of almost 30. And by keeping track not only of what buttons kids are pressing, but of how many presses it took them to get to a particular number, that encourages them to develop some strategies, again, about composing and decomposing numbers using place value, using landmark values that are defined by the places and so forth. So the worksheet has a number of these problems on it. For each problem, you reset to 0 and see how many button presses it takes you to get to that particular problem. All right. The next activity I want to show you. Okay, I did see a question asking why did we want them to minimize the button presses, and let me respond to that because that's important. We do want them to be thinking about strategies and about how place values interact with each other. And if all they do is follow a very simple rule, press 9 times for a 9 plus signs for a 9, press 8 plus signs for an 8, and so forth, they're not really relating the different places to each other. But by encouraging them to think about strategies to minimize the button presses, that really makes them think a little more deeply about how the places relate to each other and makes it less of a mechanical operation and more of a strategic process. Okay. Next activity is mystery sums, and this again is a reasoning activity in which we encourage kids to develop strategies to figure out some interesting problems. And in this activity, students can drag various letters across a dividing line, and as soon as they drag 2 letters across the dividing line, they can find out that the sum of these 2 letters, of these 2 numbers, we don't really know what the numbers are, but the sum is 12. So we know something about the numbers now. Okay, what if we dragged a 3rd number across? Oh, we only get the sum if we have 2 letters over there. All right, so A and B makes 12. A plus B gives 12. Let's see what A plus C gives. So that gives 11. All right. So A plus D gives 19. So we can keep track of the various sums that we get here. Now, here's an interesting fact. No letter has a value larger than 10, but A and D are 19. So that tells us something very interesting that we didn't know before, doesn't it? Okay, let's try some other numbers. How about D plus B? D plus B is 11, and A plus B was 12. Oops. So if A plus B was 12 and D plus B was 11, then A has to be 1 more than D, and A plus D together make 19. So if A is 1 more than D, I bet A is 10 and D is 9. So that's the sort of strategy that that we want kids to develop. It'll take them more than 4 guesses, than 4 sets of clues the first time. In fact, it might take them quite a while the first few times, but they'll start to develop some strategies that will give them interesting results. And in fact, here's another interesting pair which tells us something very important about B and C. As they do the various puzzles in this sequence of puzzles, the mystery sums puzzles, there are a number of them, and some of them are easier, some of them are harder. There are some inherent clues in here because A and D is such a large number and B plus C is such a small number. And there are fewer of those clues, and there are also some chances to make their own puzzles to share with their classmates. Okay, I'm going to show a couple more quick I'm just going to shoot through a couple of activities here on number lines, and then show some multiplication and factoring activities. I'm going to skip mystery sums 3, and I'm going to skip the zooming activity that only shows tenths to show you the zoom beyond activity. So the zooming decimals activity gets us from the realm of whole numbers into decimals. And we have a point here on the number line. In the activity, students try to estimate where this point is between, well, right now it's between 6 and 7. So the student might make an estimate to say, well, I think this number is, I think it's, let's say, 6.2 as my first estimate. Or sometimes you might have a student say, well, I think this is 6.251. And that tells you something interesting, and this activity gives you ways of talking about estimating and so forth that are very useful. So now that we've made a guess, we can press the zoom button to see the region between 6 and 7 more closely, and we can actually see that it's 6.1, 6.2. I'm sorry, I'm not an elementary teacher. 6 and 1/10, 6 and 2/10, 6 and 3/10, 6 and 4/10 is the way we generally say those. So now we can revise our estimate to say, well, I think now that it's closer to 6.435, let's say. And we can zoom again to see how close that estimate was, and that looks like it's not too far off, and we can keep zooming and zooming as we refine our estimate more and more. We also get a chance in this activity to show the actual number, and also to animate the point to see how the animation of the point, how its movement between the thousandths place corresponds to the changes in the digits up here. Okay. I'm gonna wait for a second for questions. Are there any questions I should be answering right now?
I didn't catch any specific questions. Some people are asking about where they can get access to these. I do want to remind people that you'll have access to the materials by Friday at the webinar website. Also, all of these are free activities that come with dynamic number, or on our website, they're free sample activities that come with Sketchpad, and I'll post links to those too so you can explore.
Yeah, and I'll show the links again at the end for the dynamic number project, and the links for the help menu are very simple, and I'll show you those in a moment. Okay.
We have
can we? I was going to ask Josephine if we can do that first poll now and get a sense of what grade level different people are at.
That's fine with me. Do I need to do that, or do you? Do you have a poll tab at the bottom of your control panel?
I have polls and tests, so I guess I can. Okay, launch poll. Yes. Okay, I haven't done this before. Does everyone see the poll?
So a lot of people have already been sharing in the chat panel, but if you could just fill it out on the poll as well, that would be great. And Scott, do you see at the bottom it's saying what percentage of people have voted? And then you can close the poll and it'll show results whenever you're ready.
Oh, I see. Okay, we're up to 90%, so I may as well close it right now. Sounds good. Okay, so, okay. I was assuming from the listing of this webinar that we would have more people from the elementary level than we do. We only have a total of 6% grades 1 through 5, 31% from 6 to 8. So I think maybe I will just select a couple more of the earlier activities and then jump right into the middle school and early algebra activities. So that's very helpful for my planning and for my accommodating your needs. All right. So I'm going to show let me show the factor array activity very quickly. This particular activity is an activity that kids can engage in to use the array model connect the array model of multiplication to factoring. And eventually, this same sort of model is useful when we get to algebra as well. So with 200 circles, we can see right here that with 17 columns, we don't have an even number of rows, and we'll never have an even number of rows. With 15 columns, 14, 13, 12, we're still not, oh, there, we just matched up. So with 10 columns and 20 rows, we see that we can actually fill the rectangle. So those are factors of 200. So that's some experimentation that kids do early on. And let me find the right one. Hold on one second here. Oh, I know where it is. So here's a related activity in which students are asked to multiply 25 by 23, for instance, and to do it using an array model. And this array model allows them to split up the 25 and the 23 in any way they want. So we can do it as exactly 25 by 23, or we can move down until we have 10 and 15 along the left-hand side, or maybe even 20 and 5, and we can do something similar along the top so that we have 20 and 3, and this makes it really easy for us to say, well, there's 400 here, and 20 times 5 is 100 here, and 20 times 3 is 60 there, and 5 times 3 is 15 more squares there, so it makes it really easy to add them up. This is a very nice lead-in to the algebra problem of (2x plus 3) times 2x plus 5. Because the exact same diagram with the 20 replaced with 2x, let me actually do that. I put a 2x here, so 2x plus 5 and 2x plus 3. If we replace these 20s with the 2x's, then we have the exact similar operation. 2x times 2x is 4x squared, 2x times 5 is 10x, and so forth. So it's a really nice lead-in if students understand this in the integer realm to move to the algebraic realm with that same activity. So I wanted to point that out because it's super useful in introductory algebra. Lorraine also points out that it's good for teaching the distributive property. Thank you. All right. We have some fraction activities. I'm going to show one real quickly. Let's say this one. So we have here an estimation problem. We're given a hint, but this one, I'm opening the activity itself because we have, hold on, let me find the right page here. Okay, this is good enough. For this one, we have a make fraction tool that lets students find the value by choosing the numerator and denominator. So if we were to take a look at this, estimating that, I might say, well, this is, what, maybe 5/7? Let's try 5/7. Oh, pretty close. So which way should we go from there to get it closer? How about 6/8? Hit it on the button. So that sort of estimation is a really useful activity for working with fractions, and I think take a look at that activity, the worksheet and the teacher notes. I think you'll find it very useful. Okay. So I have 5 different fraction activities that I was going to suggest you look at. That may be those may be important for middle school, but let me come back to those if there are requests for them. Let me give you a good sense of the rest of what we're going to look at, and I can go back and answer requests towards the end. I'd rather do that than take a chance of running out of time. So I want to show you the very first okay, yeah. I'm going to show you a middle school geometry activity, and I don't have a button here to show you the worksheet that goes with it, but I copied some of the pages from the worksheet, some of the steps from the worksheet. And this particular worksheet actually allows students, if they follow the whole thing, to construct this entire sketch from scratch. And that's a really valuable thing for kids to do, to have that opportunity to do everything themselves, to build the entire mathematical object themselves. We also have it in the form of a prepared sketch where you can just jump in the middle and follow a few steps and see what happens. So what we're going to do here is we're going to select the polygon and measure its area, just over 39 centimeters squared. And then we're going to observe the area measurement as we drag in several different ways. Point E shears the polygon by dragging E back and forth along a line that's parallel to the two sides of the parallelogram. And we don't see much happening with the area there. We can drag point D or point F to change the base. So if we make the base longer, the area gets bigger. By dragging either D or F, we have similar results, although the D changes the shape and F only changes the width. So those are differences, but they still both change it. And we can also drag the parallel lines up and down. So we see that the area responds to everything we drag except for the shearing motion. So this is a lead-in to figuring out that it's actually the distance between the two parallel lines that's critical for figuring out the area of a parallelogram. And if we measure both of those segments, and if we were to use Sketchpad's calculator to take the measure of EH times the measure of FD, we find that we get the exact same result. So that's what students accomplish in the course of this activity. You may also like to change the label of the base of the parallelogram to call it base, and to change the label of that vertical line to the height, so that we end up with a formula that indicates we want to take the height times the base. Okay, so that's parallel pairs. I'm next going to show parallelograms. Actually, let me do this drag test, and I'll just pass through the parallelograms one. This is part of an activity called Quadrilateral Pretenders, and I said I would show you where to find some of these. Well, Quadrilateral Pretenders is right there in the Help menu. If you go to the Help menu and choose Teaching with Sketchpad, the Teaching with Sketchpad page comes up, and scrolling down just a bit, there are over 40 sample activities. A number of the activities I took came from elementary grades. This particular one comes from the middle grades. And if we just scroll down, we see the Quadrilateral Pretenders activity. You can download the activity files right here. So many of these activities you can get to right straight from Sketchpad's Help menu. The Help menu, by the way, with the welcome videos, the tips on using Sketchpad, teaching with Sketchpad, sample sketches and tools, the reference center is the most underused feature of Sketchpad that there is. Okay, let me pause for a moment and see what questions there are that I should be asking, that I should be answering.
A couple of questions. The last three just popped up. You could address those. And we also had an earlier question about whether these will work with Sketchpad 4.
So many of the activities will work with Sketchpad 4. The activities being developed under the Dynamic Number project are Sketchpad 5 only. It is possible in many cases to save a Sketchpad 5 sketch in Sketchpad 4 format, but there may be information lost. So basically, let me say that the activities that come from Sketchpad Lesson Link, which we'll mention at the very end, those are all available for Sketchpad 4. The ones that come from the Dynamic Number project are available only for Sketchpad 5. So that's the distinction. Most of the activities from the Help menu are also available for Sketchpad 4. Is that it? Can I move on?
Yes, I would say so. Well, let me answer a quick question. Diana asked if you can get access to these without internet. You would have to download those when you do have access to the internet, but then you can keep them on your computer. And Monica asked, is there an activity on transformations? I don't recall specifically if there's one at the Learning Center, but I would suspect so. Do you remember, Scott?
There are definitely activities related to transformations. You'll find them. I'm not sure if there are any in the middle school section here, but there are definitely activities related to transformations in here. Here we have tessellations. Use rotations as the very first geometry activity.
And I think there might be some at the elementary level as well, with reflection perhaps.
I think that's right.
Okay.
Absolutely.
That's great, Scott. Thank you.
Here we have one, and here we have another. Indeed. Okay. So the quadrilateral pretenders activities are activities that help students to master what the ideas of what quadrilaterals, of how they can categorize quadrilaterals correctly. And the basic idea of these activities is that we have 4 quadrilaterals here, some of which are pretending to be squares and some of which really are squares. And by that, I mean to say that some of them are constructed so that no matter what we do with them, they always remain a square. That's certainly not the case for this first one, because we can drag it into all sorts of shapes, and we'll later on, specifically when we look at parallelogram pretenders, investigate the properties of this shape, because it does seem to be a parallelogram. Okay, so we look at this one right away. We know from the very beginning that this one certainly was only a pretender and not a real square. Let's try this one. Okay, that's looking pretty good so far. So that one doesn't stay a square either. Ooh, and in fact, look at that. My goodness. Okay. So do we have any of these that stay square no matter what we do? That one looks pretty good. So one of the 4 always stays a square. And by engaging in these which always stay a square and which don't, which always stay a parallelogram, which always stay a trapezoid, it really helps students to get the idea of what those various shapes are. And the last one from the geometry category that I want to show is the pyramid one. And I'll just breeze through this real quick. In this activity, students are looking at the surface area of a pyramid, and they have the ability to look at the three-dimensional view, and I can actually leave that animating while we do some manipulations here, so we can keep an eye on that three-dimensional view while we change the height by dragging a point on the net. And if you actually print this net out, students can fold this net to form the exact figure that they're seeing here. So we can change the height, we can change the radius of the base, making it larger and smaller, and we can even change the number of sides. So now I'm down to a four-sided, a square pyramid, pentagonal pyramid, even a triangular pyramid, and I can increase the number of sides to the point where I'm also thinking about cones. So this is a nice surface area activity with a nice visualization that the kids will enjoy and be able to take advantage of in figuring out how you get the surface area of these particular shapes. All right, I want to show one more activity real quick and then take requests. The other one I want to show, hang on a second, let me stop this motion. There we go. Okay, so now things are behaving normally. The other one I'm going to show very quickly is the Mellow Yellow activity. In this activity, we have three different representations of motion. We have a motion graph, we have a story, and we have Mellow Yellow herself on the way to the corner store. If we click Go, then Mellow Yellow proceeds to the corner store based on whatever the graph looks like. So this is a nice way of showing simultaneously both these representations and noticing, for instance, the aspect of it that often gets students confused, that when the slope is negative, that means that Mellow Yellow is going backwards. Not that she's going down a hill, but that she's going backwards. So now we have the job of trying to connect this motion and this graph to the story. Did she run toward the corner store as quickly as possible but stop and rest? We didn't see her rest at all. So students need to change either the graph or the story. In this case, we're going to ask them to change the graph. She ran towards the corner store quickly. So after a little bit of work with these graphs, we can make that first section make her run quickly. In the second section, we can make her stay right about where she is, and then she can walk for the last part. And let's see if that's correct. Reset and go. She's running towards the corner store, run, 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 stopping and resting, and walking the rest of the way. So that process of getting these three different representations in concert with each other is a very interesting and useful one for kids, and hopefully will help them to eliminate some of the misconceptions that they often have. Okay. That gives you some sense of the breadth of these activities that we have available for you in both the help menu and the through the dynamic number project. The help menu, by the way, I saw somebody asking if Mellow Yellow can be ready tomorrow, and absolutely go to the help menu and grab it. So I'm happy to answer questions, to show some of the activities I've skipped. I've skipped a bunch of the fraction activities. There's an activity on adding and subtracting positive and negative integers that's very nice. There's an early activity on simultaneous equations called circles and squares that's nice. And there's a data activity on the mean and the median. I did see a couple of questions coming up on iPad, by the way. All of the activities that you've seen today that don't involve the use of construction tools, either either custom tools or the regular construction tools, all of those can be used on the iPad. The iPad Sketchpad Explorer app, which you can get from the App Store, can show all of these. So for instance, this Mellow Yellow activity we've just been looking at works just fine on the iPad. Josephine, what is the feeling of the group?
Oh boy, there's been a lot of questions coming in. So I haven't gotten a sense of what specifically people want to see next, but feel free to type that in. We did have a couple of questions when you were showing the net, the three-dimensional pyramid net. People were asking if there could be a calculation of the surface area or the volume as well. And while you're answering that, I'll scan through for some other questions.
So the answer for surface area is yes. This particular activity doesn't investigate the volume, and we don't have any built-in way of measuring volume. But the actual activity leads them through the process of saying, okay, the base is made up of triangles. If we find the apothem and the base of this particular triangle and then multiply it by the number of sides, we can find the area of the base. So taking that surface area and then this length times the slant height, and they can imagine where the slant height has to go because they're making the connection between the three-dimensional view and the net. So by the time they're done, they're able to develop themselves the formula for the surface area of a pyramid based on the slant height, the apothem, and the length of each side of the base.
Okay, thanks. We've also had a few people saying they would love to be able to program things like this themselves and asking about more webinars. We have had a couple of more advanced webinars, but this is a lot to cover in a 1 hour. So I will let you in on a little secret. We're developing a 6-week online course that's on programming in Sketchpad that is enough time to get you through to hopefully be able to program things as fancy as a lot of the things that Scott has done here. So that won't be ready for at least a couple of months, but keep posted for that. We had a question about what do the Venn diagram ones do? Scott, did you have, oh, I see. You have a couple of tabs there on Venn diagrams that someone was interested in. We also had a question about whether there were any Algebra 2 activities, which I think is out of the scope of this presentation, but maybe you can address that.
Okay, quickly, Algebra 2 is out of the scope of this presentation, but again, teaching with Sketchpad, take a look at the sample activities, and under algebra and under trigonometry, conics, and calculus and beyond, you'll find lots of activities for more advanced topics. The Venn diagrams, actually, this isn't exploring Venn diagrams, but it's the Venn diagrams showing the relationships between the different definitions of quadrilaterals. And actually, there are 2 Venn diagrams here, one of which shows the diagram using the inclusive definition of a trapezoid and another showing the exclusive definition of trapezoid. The definitions used are different in different books and also in different parts of the world. So that's where the Venn diagrams was. Next question?
Oh, there's so many. Actually, there are not so many questions, I don't think, unless I've missed them. I will address in the chat panel the question on webinars and 6-week courses. There have been a lot of suggestions for things that people would like to see. A couple of people have said statistics. Somebody has asked about an introductory lesson on symmetry. You know, there are many diverse questions. What can I do with circles, central angles, etc.? I'd like to see the integer one more on fractions. So we're kind of all over the place. So I think you should pick what you want to show and see what you can get to. Oh, and we have 4 minutes left.
Okay. Well, I can show 2 activities at 1 activity per 2 minutes, right? So here's here's one page of the mean and median activity. And this, again, is from the help menu, and so is also available in Sketchpad 4 format. And the orange bar here indicates the median, and kids have the opportunity to drag one of the data values along the number line and see that we're not getting any change in the median at, whoop, oh, look at that. We are getting some change in the median, but only within a certain range. So what if we drag this? Look at that. So the behavior of the median is very interesting here. If we also show the mean, then we can get some sense for how those are rather different measures of central tendency, and we can make all kinds of observations about what data points affect the mean and which data points affect the median, and begin to understand why that really is and what the huge difference is between these different measurements. So this activity actually has 2 pages to it, one of which has an odd number, has 5 data points, and one of which has 6, just so that you get to experiment with both even and odd numbers of data points and see how the difference between those two affects the value of the median. So that's one activity. The other one, maybe given the level of, let me just quickly show the subtracting on the number line. Actually, I can do both of them. So adding on the number line, we're trying to develop a good visualization for students of how to add and subtract numbers on the number line. And in this particular visualization, kids can drag to add any 2 numbers they want. So for instance, we might want to do -11 plus 5. And if we click the add button, we get to see the -11 transferred down to the number line. We get to see the +5 transferred to the number line. And intentionally, it doesn't show us the answer. We have to actually follow the dotted line here to the red mark and figure out that the answer is -6. And that, by not showing the answer, we encourage kids to actually figure it out from the 2 numbers that they have here and so forth. The visualization that goes with subtraction is a little different, because when we subtract, we have to take the number we're going to subtract and flip it to go in the opposite direction. So we get to see here what happens when we subtract a positive value. We can reset and see what happens when we subtract a negative value, and see how those 2 operations really, it's the same way of thinking about it, whether we're subtracting a positive or subtracting a negative. And if we can internalize this view, then memorizing when you subtract a negative, you do such and so, those formulas become unnecessary for kids, because they have the visual that they can remember much more effectively than they can remember a rule stated in words. So that brings us to the end of the hour. I want to leave one last screen up, which indicates where the activities from the help menu are. This is Sketchpad 5 only. Sketchpad 4, the activities from Sketchpad 4 have to be gotten from Sketchpad lesson link, which is listed down here. It is possible to get a trial subscription to Sketchpad lesson link, which will include most of the activities that come from the help menu for Sketchpad 4. Dynamic number activities are at this URL. You will get information on the zip file for the webinar, which includes I believe it has all the activities that I showed today, and one movie, and you'll have a link to the recording of the webinar as well. Josephine, any other closing words?
I just want to thank everybody for coming. We had our largest number of participants ever today, so if you didn't get your question answered, I'm really sorry about that. There was a lot of chatting going on, and I appreciate your involvement, but I'm sorry if we didn't answer a question. I did mention that Sketch Exchange is a resource where you can go to ask more questions and get more resources. It's free. It's a community site with a forum. Scott and I both monitor it, so if you have more questions, you can ask them there about how to do anything that we didn't cover or where to find a great activity on some particular topic. If you have great activities that you've also developed, you can share them there. We'll stay on for a few minutes, so if you have any more questions that you want to get answered, we'll stay and answer them, and Scott will leave up this slide with URL. You're going to get, when you exit this webinar, you'll get a poll, or I'm sorry, not a poll, but a survey, and I heard a couple of people were saying that the audio was not great in this webinar. So if you have that problem, if you will indicate that in the survey, we would really appreciate it so we can see how big of a problem that was for how many people. And I just want to thank Scott very, very much for his presentation. We had a ton of information shared here. And thank you, everyone, for your participation via the chat panel. And thank you to Kendra for answering questions as well. Okay, so Scott and I are going to go on mute. We will continue to stay for about 5 minutes and answer questions if you have them. Thank you, everyone. Okay, everyone, I'm going to give you about 1 more minute to type in a question if you have it, and then we will be